If we fill a properly sized container with water, we can place inside it a glass jar with 1 liter capacity, which is also filled with water and with its lid on. The jar goes to the bottom of the container. If we now take out the jar, empty it, and weigh it, it will weigh about 400 grams. That is, the empty jar with its metal lid on. Now we put the empty jar in the container, of course, with its lid on. We will see that the jar floats, slightly immersed into the water. The logical thing is to think that the jar now weighs less, which is true. However, there is more to this explanation. When we immerse the jar in the water of the container, we see that the water level goes up in the big containers. This is because when putting the jar into the water, it has to displace, that is, to remove enough water to have space to fit in. This displaced water raises the water level of the big container, and not only that, but it exerts a force opposing the jar going into the water. We know that a liter of water weighs 1 kilogram. So when we put the full jar the first time, the jar and the water it contained weighed 1,400 grams. 1,000 grams of water plus 400 grams of the jar with its lid. In the year 270 BC, Archimedes of Syracuse stated the principle that bears his name, according to which any object immersed totally or partially in a liquid experiences a vertical upward thrust equal to the weight of the liquid being displaced. When the jar, either full or empty, is put into the large container, it has to displace or push away an amount of water equal to the volume of the jar, that is, an amount of water of the same size and shape as the jar, for the jar to take up that space. The displaced volume, according to Archimedes' principle, exerts an upwards force, trying to push the jar out. If the jar is empty, the weight of the jar will be 400 grams, which is the weight of the glass plus the metal of the cover, and the upward force will be 1,000 grams, which is the weight of the water displaced by the jar. This force of 1,000 grams will easily push the jar up, leaving about 1/3 of it dipped into the water. If the jar is full of water, it will weigh 1,400 grams, against 1,000 grams, the weight of the water being displaced. This will make it sink to the bottom, because its weight exceeds by 400 grams the weight of the water being displaced, that is, the weight of the glass and its lid. Put another way, if the jar, by its shape and size, displaces 1 kilogram of water in the big container, that kilogram of displaced water will be pushing the jar upwards. If the weight of the jar is greater than the weight of the displaced water, the jar sinks. But if the weight of the jar is less than the weight of the displaced water, it will float. The same thing happens with a boat, whether iron, aluminum, or steel. If the boat weighs some 2,000 tons, but it displaces 10,000 tons of water, there is an upward force that pushes the boat up, a force equivalent to 10,000 tons, which easily surpasses the 2,000 tons the boat weighs.